testing, testing, testing the audio stream. Audio. Are we getting audio? Audio. Okay. Oh, is that what it is? I had it muted over here. Ain't that a bitch?
So many settings.
Yeah, I was when I told you guys, hang on, I'll be right back. Jamal had called me, and he told me that the stream wasn't sending audio out, and I wasn't. Oops, let me turn that down. And I told him that I wasn't watching the stream. Like, I got so many different windows going on here between the Wirecast, where I'm editing and linking the green screen together, and the Zoom window where I'm sending the video to you guys, and the third screen over here where I can see my green screen overlay, and then doing the demo. It's like I'm doing the job of like 3 or 4 people over here. And
Yeah, you're the producer and the...
yeah, I'm the talent, I'm the director, the producer. And he's like, yeah, I've never seen anybody do a live stream by themselves. There's always a director or producer or something. And he's like, you're doing all this live streaming and green screening and doing the demo. And I was like, I can't respond to messages. He's like, I sent you a message on the YouTube channel saying I can't hear you. And I was like, I'm not even looking at that window, dude. I started the stream and then I switched over to my demo. And when I was trying to watch everything earlier, I messed my demo up. So all I'm paying attention to is the demo. And as a result, I just sent some stuff out completely muted. So I had the audio turned on Wirecast, which the first time I did the demo, I didn't have the audio turned on Wirecast. Second time, I made sure I had the audio turned on Wirecast, but I didn't have it turned on the YouTube stream. So third time's the charm, I guess.
Yeah, well, and hey, it's day one, and the good news is everything works. But ironically, it's like, where's Jamal? Because isn't he really the production?
Yeah, right. He's
He's the guy we need.
right. Well, he's in Seattle, and I'm in San Francisco, so maybe I need to go to Seattle to do the next one, I guess. I've actually got to go to Seattle tomorrow to mow my lawn. That's actually what he was calling me about, because he's dropping my lawnmower off for me at the repair place. And they told me that your lawnmower cannot be repaired. It's dead. You need a new lawnmower. So that was the first bad news. The second bad news is, dude, your audio's not on. So yeah, this is definitely the beta run of doing this stuff, and I think it would be much easier if I had Jamal or somebody here to run the switchboard on the Wirecast here, so I can make sure that everything's going out the way it's supposed to go out.
Right on.
But I think I've got it now. Like
I think it's great.
the way I have the green screen set up now is not how I had it originally. Originally, I was switching the camera on and off, and I found that was just way too difficult to be able to manage that, turn the camera on and off without looking like I'm looking down at the screen, turning the camera on and off. So that's why I'm doing this walk onto the screen to talk and then walk off to do the demo. Before, I had a camera on me while I'm sitting at my desk, but whenever I went to switch the screen or something, you could tell that I was concentrating on something else.
Right,
So
right.
you only get to see me when I stand up to make a point.
Don't forget record.
And we'll hit record over here on the Zoom meeting. Then we'll double check the stream output. Make sure it's not muted. Double check the audio. Testing audio with delay. Test, test. Double check the audio. Testing audio with delay. Test, test. Good. Audio's going out. And we are live on YouTube. Alrighty. Switch back over here. Zoom meeting's good. Good there. Alright. And this time in Visual Studio. Okay. Intro. Ah. Alrighty. Another live stream demo here. This is a test-driven development demo in C#. And we are going to follow the TDD rhythm here. So that means we are going to write a failing test, and then we're going to run the test to see it fail. Now this, if you haven't seen my rants on the TDD rhythm before, this is my expanded version of the TDD rhythm, where we have expanded from the traditional TDD rhythm that just includes write a failing test, write just enough code to see it pass, and then refactor as needed. I've expanded that to include run the test and see it fail. The reason that I've included this is because as you're writing your failing test, if we're following the TDD rhythm, we write the test before we write the method under test. And if you've written any code at all, you know that if you try to compile a solution that references a method that does not exist, or a class that doesn't exist for that matter, you get a compile error, aka a red squiggly. So to avoid the red squiggly and to actually be able to run the test and see that it fails, we have to create something called minimal project structure. If you're curious about what that is, see my blog post on minimal project structure. But minimal project structure in a nutshell basically means that we create the project that contains the classes that will eventually contain the methods that we're trying to test. But we create just enough of that project so that our failing test can compile. All right, so that's why we've expanded the TDD rhythm to include run the test and see it fail. Then we write just enough code to pass the test, and then again expanded to include run the test and see it pass. Beyond that, refactor is needed, as in the traditional TDD rhythm, and we've added run all the tests to see them pass, just to make sure that writing the additional test or writing the additional method did not corrupt something in our test suite, causing older tests that we're passing to fail now. So let's go ahead and jump right in and do this TDD test using a stack utility in Visual Studio Community Edition version 2017, which is free, by the way. So if you want to follow along with this demo, feel free to download Visual Studio Community Edition and follow along. You'll also find step-by-step instructions on the blog. Okay, so first thing we're going to do here is go ahead and go into Visual Studio. And in Visual Studio, we're going to start a new project. Our new project is going to be a test project. And we will call our test project stack test. By the way, you'll note that stack test became the name of the namespace because I let the default ride there. So our class is called unit test 1. But I would be much happier if that class was called test stack. So we're going to rename it to test stack. There you go. Now we have the stack test project and the test stack class, and we have a method here called test method 1. We're going to change that to stack test. And in that test, we're going to do just the test for the existence of the stack class. We're going to put the stack class in a project called stack util, short for stack utility. And the class is going to be called stack. We're going to put in a variable called stack lowercase, and we're going to create a new instance of the stack util stack class. Let's give ourselves a little more screen real estate here. Stretch these windows down. And then we are simply going to check and make sure that the stack variable is not null. So we're going to do an assert dot as it is not null stack. Now, since we have not yet created our stack utility project, we're getting red squigglies here. So we will create minimal project structure by adding a new project. Windows desktop project. Where are you? Class library project. And we're going to call it stack util. And click OK. So now we have our stack utility project with a single class called class1, which I'm going to delete. Now we have no classes. We have no class. We're going to now make a reference in our test project to our stack utility project. So it knows there's this thing out there called stack utility. And that should make our red squigglies go away over here. Unless I spelled it wrong. Deleting of that class 1 deleted the reference to the namespace. So let me add a generic class back in here again. Add a new class. Class 1's a fine name for it. There you go. So now the namespace reference is back. So it recognizes that we have stack util, but we have no class called stack. Now we could generate a stack util class in a new file. But because we want full control over where and how that stack class gets created, we're going to use the generate new type dialog box. And here, we're going to tell it that we don't want the stack class to be created in our stack test project, but rather in our stack util project. And then it switches to create that stack class as a public class in our stack util project. It's defaulting to creating it in the assembly info file, but we want it to be created in a new file called stack.cs. And then we'll click OK. Our red squiggly goes away, and over here in our stack util project, you can see that it created a new class called stack. Now we can delete that class 1 class. So now if we run our tests, we should be able to see that existence test pass. And there you have it, our stack test. Testing for the existence of the stack class is passing. So now we know we have minimal project structure. We can continue on with additional test methods. This time, public void. We're going to do an IsEmpty test. IsEmpty test to see if our stack is empty. Using Java syntax and C# here, bear with me. All right, so in our IsEmpty test, we want to make sure that our stack class, our stack util, dot stack equals new stack. Has a method called isEmpty that returns a Boolean. So we're going to do an assert dot true is true. we're going to check and make sure that stack.isEmpty returns true. Now, of course, we get red squigglies here because there is no method called isEmpty. So we're going to use the code generation tools here and have the method stack.isEmpty created for us automatically. And you can see by the preview window here that we are going to create a new method called isEmpty that throws a not implemented exception, which, as I'm sure you can imagine, will cause our test to fail. If we have it go ahead and generate that method, you can see our test is happy now, but if we run our test, we get a big fat failure on the isEmpty test, but we have success on the stack test. If we highlight the isEmpty test and look at the test results here, we can see that this test is failing because the isEmpty method threw an exception. The exception that was thrown was system.notImplementedException. The method or operation is not implemented. So that tells us that the test is there, that the method is there, but it's throwing an exception, showing us that the code generation tools were used to create this method. Now, before we continue, I want to take a moment to bring up an interesting point about these code generation tools and using this method for test-first development. Now, in most environments, in most organizations, you may or may not have a QA team. If you don't have a dedicated QA team, you may at least have a team member that's a developer that for this sprint is responsible for writing tests. Be that as it may, however you're dealing with this situation, if you have a team of testers or a dedicated individual that has nothing to do for that first sprint or two while you're building enough of the solution that they have something to test, if those testers or those QA people are not developers and don't write code, you can still have them help out with test-driven development. Some of the things that they can do are building those structural tests. Those structural tests don't require in-depth coding knowledge. We write one of those structural tests, and then we can simply copy and paste to create additional structural tests. In this case, I'm testing for the existence of the stack class, but we could very well be testing for the existence of a customer class or an orders class or a registration class. Whatever it is that your solution does, there's going to be many different classes and objects. So the QA team could help out with that by writing these structural tests by simply copying and pasting templates that you provide them with. In addition to that, they can enforce naming conventions and layering structures by creating these tests first. With this isEmpty test that I just did here, all that we need to know is that we have a class called stack that has a method called isEmpty that's supposed to return true. So we could provide our QA team with a series of templates for isEmpty test, for isNotNull test, for our equals tests, and they could simply copy and paste those test templates and then specify the method that we're supposed to be testing and then use the code generation tools to create those methods. And then all the developers have to do is come in and write the implementation code for each one of those methods. And as you saw here, if we don't write the implementation code for the method, what we get is a method not implemented exception when we try to run the test. The value that that provides, in my humble opinion, is that we can tell that there's this series of tests and there's this series of methods that were created for the tests, but those methods have not yet been implemented or completed by a developer. So if you're in a continuous integration type environment, as you check this code into source control, you get a bunch of failed tests that illustrate that some work has been done, but other work has not been done by the developers, and only the test has been implemented. I think that's a very valuable reporting metric, so you can see where you have tests and no method implementation, and where you have method implementation that's failing because the method was written poorly, or where you have no method implementation and it's failing because there's just no code written there. So something that you can use to have your testers, your QA team, help out with getting the developers going on test-driven development, even if those testers are not developers. All right, so let's continue on here with our stack. So our stack isEmpty test is failing because we need to write some code in that method. So let's go ahead and jump over to our isEmpty method using F12. And here, instead of throwing an exception, we are going to follow the TDD rhythm, which says we should write just enough code to pass the test. So in this case, our test is expecting a true to be returned. So let's just return true. And now we run all tests, and our isEmpty test passes. Obviously, that isEmpty test is going to come back to haunt us later on, but we'll go ahead and let that ride now, following the TDD rhythm to write just enough code, the minimal amount of code to see this test pass. Let's continue on with our testing, and we will write a test for the next method. In this case, our next method will be the push method. So we will first write a test for the push method, public void push test. And in our push test, we are again going to create an instance of our stack util .stack class, store it in a variable called stack, and set it equal to a new instance of stack util stack. And then we are going to push a value onto the stack. So in this case, that's going to be a stack.push, and we'll push hello world, because you can't have a programming demo without at least one hello world. So there's our stack.push, and we would expect that our push method returns a string or some value that lets us know that things went as expected. So we'll call the value that's returned the actual value, and then we will do a assert dot r equals, and we will compare the expected value, which in this case is hello world, with the actual value that we stored in our actual variable, which should also be hello world. Here we have a red squiggly indicating that our push method does not yet exist. So we'll use the code generation tools to generate our push method that throws an exception. Obviously, running that, we will see our exception is thrown, and that test does not pass. Then we can go and refactor the method to include the code to pass this test. Now again, if we're following the TDD rhythm to write just enough code to pass the test, I could do a return v, which will pass that test. But we've provided absolutely no value here. So let's move on to the next test. And here, we'll do basically the same thing that we just did, but we're going to verify that the stack is no longer empty after pushing a value onto it. So we'll call this push isEmpty test. So instead of doing this r equal assertion, we'll do this is true, or rather is false now, because we want the stack to be empty. So here we want to now call stack.isEmpty, and stack.isEmpty should return false since we've pushed a value onto the stack. Now when we run that test, we see that all of our other tests that we're passing were really giving us false results. So now we need to go back and refactor those methods so that they pass using the appropriate values. So back in our stack test, or in our stack class, we need to modify this isEmpty method so it's actually returning the values from our stack class. So we're going to create a stack class, or stack based on an array list. Oops. Oops. So array list, we're going to call it stack. Oops. And set it equal to a new instance of our array list. So now our stack we can check to see if its length, oops, stack.length, where are you, length? Sorry, stack.count is equal to 0. And if our stack.count is equal to 0, it'll return true. Otherwise, it will return false. Let's run that. Oops, not run, but run our test. We still get passing for the isEmpty test, but our push isEmpty test still fails because our push is not actually adding a value to the stack. So let's resolve that issue by using our stack and adding a value to it. And the value in this case that we're going to add is the string. The add method simply returns an integer, indicating the index of the value that we returned. So we'll have to change our return value to an integer, go back to our test. Oops. Oh. And here, instead of getting back a string, we'll be expecting an integer. I think what we want here now is our not equal. We don't want -1. We want anything but -1, and we pass our test. Down here for our push isEmpty test, again, we want an integer back, and then we want to make sure that the isEmpty is false. Let's run our test now. And now we get 4 tests of 4 passing. So that tells us that our minimal method implementation was sufficient until we tried to test the methods together. And now that we're testing push with isEmpty, we actually push something in, and we check to see if the stack is empty. It is no longer empty, so we can continue on now. So we've got push test, push isEmpty. Now I suppose we can continue on with a pop test. So to do a pop test, we'll obviously have to push something in. So we'll copy this code because less typing means less typos. And instead of push isEmpty, we'll call it push pop test. Push a value onto the stack, and then we will pop the value off of the stack. We don't need to get the return value of the push method because that's not what we're testing. Call stack.pop, and we should get back our expected value. Now, so that we don't have typing errors, and so that we can pass continuous inspection, we're going to set this expected value into a string variable called expected, and we'll set that equal to hello world, and we'll push the expected into the push method. And then we want to do an assert r equal, and we want to compare the expected value with the actual value. Excuse me. Now, aside from the fact that our pop method does not exist yet, we're all set. So let's use the code generation tools to create our pop method with its exception thrown. Now we should be able to run this test and see it fail. Test is failing due to method not being implemented. So let's go and implement the method. We'll change this pop method from throwing an exception to getting a reference to our stack, doing an add. Oops, no, this is pop, sorry. Doing a reference to our stack and referencing item 0 from that stack. And we will simply return item 0 from the stack converted to a string. Run our tests. And now we have 5 of 5 tests passing. So far, so good. Go back to our stack test. And we will add an almost identical method for peak. Excuse me. So this will be a push peak test, where we do pretty much the exact same thing, except for we call the peak method, and we still expect that the values that are returned are equal. So all we really have to do is generate our method for peak. And if we go and look at our peak method here, for peak, we're basically going to return the same value that we got with our pop. And that should pass our test. Now you'll notice that pop and peak have the exact same code. That's because we haven't fully implemented pop yet. But we may not be aware of that until we write more robust tests. So now we're getting 6 of 6 tests passing. But what's really supposed to happen when we pop is the stack is supposed to be empty. So we're going to copy this code again. And we're going to do a push pop is empty test. And instead of comparing to see if the values are equal, we now expect that assert dot is true is what we would get if we did a stack dot is empty. Now if we run that, we're going to get a big fat failure because the stack is not empty because we didn't remove the value from the stack after we did our pop. Let's go back to our stack class, and here we'll set this value into a string called result, and we'll set that equal to the return of the stack index 0. And then before we return the result, we'll do a stack dot remove at, and we'll remove at index 0 to get rid of the item at the top of the stack. And then we'll return our result. And now we have 7 of 7 tests passing. So now, let's do a multi-peak. Just to make sure that when we do our peak, if we peak twice, we get the same results. Because the peak method should not remove items from the stack. So if we do a, oops, don't need the variable here for the first one. If we do a stack peak peak, we should still get the same results. Certain that will pass because there's nothing wrong with our peak in our stack. That's great. So now we have to verify is if we do multiple pushes and then pop, do we get the same results? We'll call this one MultiPushPop without the IsEmpty. This time all we're going to do is we're going to add an additional method or additional argument for expected to, and we'll call it goodbye, cruel world. And we'll push onto our stack both expected 1 and expected 2. And when we pop, we would expect that we get expected 2 as our actual value. We run that. Wah, wah, wah. We get test failure because MultiPushPop into our array list. Our array list is actually a FIFO, meaning first in, first out. And what we're looking for here is a LIFO, where the last thing onto the stack is the first thing to come out. So we have to manually change the order in which things are added to the stack. We can do that by coming over here into our push method and doing, instead of just an add, we do add. Let's see here. I guess we have to do an insert. Yeah, we'll do an insert at index 0 to make sure that we're adding it at the top. And again, this returns no results. So we'll do our insert up there, and we're going to change this back to a Boolean method. So if all goes well, we return true. Back to our test method. Where's our reference to that Boolean? There it is. And this can just be is true now. All right, a little refactoring to support that change. And now we can run all tests, and our MultiPushPop should pass. Alrighty. So in conclusion here, this was a demonstration of a slightly more in-depth TDD demo. And a couple of things that were illustrated here is the first time through, writing just enough code to pass your tests might produce incomplete results. As you saw, our IsEmpty method just returning true passed our first series of tests. But once we push something onto our stack and expected to get the same values back off of our stack, at that point, our isTrue or IsEmpty returning true was no longer valid, because once we push something onto the stack, we expect it to not be empty. So we had to go back and refactor our IsEmpty test to return an actual value based on what's in the stack, not just a literal true. Beyond that, other methods that we tested worked great when we tested them by themselves. But once we did a more complete test, testing to see what happened if we pushed multiple values onto the stack and then tried to retrieve those values back off of the stack, we saw that our tests that were passing originally started failing. The point that I'm trying to make here is you have to make sure that you have a complete test suite, not just 100% code coverage, but coverage of all the possible scenarios under which that code might be executed. Because I guarantee you, the first thing that the end user is going to do is something that you haven't tested. So you want to make sure that you have complete code coverage. So that's why we write the test to see it fail, write just enough the code to see it pass, and then we refactor as needed to make sure that the test pass under all possible conditions that the user might execute that code. So that concludes my test-driven development demo in C#. Tune in for the next demo and subscribe to the channel. Thanks for watching.